Hello, friends. Welcome to our YouTube channel Code with Robin. In today's session, we will discuss binary system in computers. As you can see on my screen, we have already discussed in detail why computers understand binary 0 and 1s. If you have not watched our previous video, I would highly recommend do watch it. In order to understand binary number system, it is very important to first understand what is decimal number system. So you might have read or learned in school already
Four
how
is the
decimal number
ones,
is.
two is the tens, one is the hundreds, and two is the thousands.
Exactly. So 2124.
Yeah.
Excellent. So 2 is a thousandth place. So but how we write normally, if we have to tell to our viewers how decimal numbers we write. So if it is 1985 thousandth place, hundredth
Nine.
place, this is
Yeah.
how it. Let's say we want to write
Two,
1986. Now can you tell me what will be at?
one,
Okay,
nine,
9 is a hundredth place. Yeah.
eight,
8 is at which place?
ten,
Okay, and one
six.
place 6. Excellent. This is how you have learned in school the decimal number
Yeah.
system, because the decimal number system always has base 10. Why it has base 10? Because you have digits 0 to 9. So total count becomes 10. So you can interpret the information in decimal number system. So this is nothing but the raised to power 10 raised to power 3000. So
Hmm.
that's why thousands place you have these numbers. Okay. Now going back to our slide. So now we want to understand what is binary number system that computer understands. Since computer understands only zeros and ones, you can see here all the decimal numbers from 0 to 15 and its equivalent binary numbers. So each bit that is stored as 0 or 1, it is known as bit.
Bit.
And when you store 8 bits, it becomes
A byte.
byte.
A
But
bit is either one or zero.
exactly, a bit is either 1 or 0. Now going back to our sheet, this is how the binary number system interprets this information. How it makes it, we can tell. So we have numbers 1, 2, 4, 8. As I said, computer only understands 0 and 1. So that's why it has base 2. That's why it is always 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and so on.
Yeah.
Not like your decimal number system where your base is 10. There go you ones place, tens place, hundredth place, because base is 10. But in computers, in binary number system, base is always
Two.
2. So if I have to write number 0,
Zero, 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 zero.
good. So it will be 0 0 0 0. Okay, what will be number 1 if I have to write?
Zero, 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 one.
0001. Why? Because anything 2 raised power
Yeah.
0,
This
this is
zero,
1.
one.
Okay, how you will write number 2 in binary?
Zero, zero, one, zero.
Okay, what? Why 10? Can you tell?
Because two raised power
1
one
is
is two.
2 and number 2.
Yeah.
Okay, now how you will write 3?
Zero, zero, one, one.
Good, excellent. How you will write number 4?
Zero, one, zero, zero.
Excellent. This is how you will write equivalent. This is your decimal number. This is its equivalent binary number. Okay, and this is how the sheet goes like. Let's say we want to write for 15. So you have 1111 as a binary. Why? Because 8 plus 4 plus 2 plus 1
Is 15.
gives you some 15. That's why the number 15. So this is how it is written. Now question comes, we have a lot. This is just decimal numbers that got converted into binary, but in our keyboard you might have seen lot of characters. You have space, you have a b c d, small, capital, different keys. So how computer will understand that information? Let's say you want to store code, code into computer. How computer will understand?
By ASCII.
By ASCII. So somebody has to define that system. So who has defined it? It is American
American
Standard
Standard Code
Code
for
for.
Information Interchange.
So we defined these standards. That what they defined, they said, okay, this will be the decimal number for the letters and the special characters. So example, if I have to write code C, what will be its equivalent decimal number?
67.
67. So if I write 67 here as decimal number,
Yeah.
when I convert it, you can see this is the binary number which I get.
Yeah.
Okay, so if I now want to write a text,
C.
and I want to write a text C. Okay, CODE I wrote.
Yeah.
Okay, look, CODE. C, this is same as 67. Okay, in our ASCII table, 67. So this is how it converted. This is
Yeah.
67.
Yeah.
Then what is O? Can you quickly check what is O? Capital O, 79.
79.
This is how 79 gets converted into binary. Okay,
Yeah.
and how it gets converted, it's the same technology.
Yeah.
This we extend it to 2 raised power 7, 8, it goes on. Okay, this is how. So now, as I said, 8 bits is equal to,
8 bits is equals to
so
1 byte.
see, exactly, 8 bits is equal to 1 byte. So how many bytes are, if I write cod, how many bytes it is taking?
4.
Yeah, exactly, 1 byte, 2 byte, 3 byte, 4 byte. So we will do a small POC here. We will show, this is our empty notepad. So if I write CODE into it, CODE, okay, so essentially it should take how much bytes?
4.
4. When you see its properties,
4
how many
bytes.
bytes it took?
4 bytes.
4 bytes. So if I will write it code with Robin,
15
if I
bytes.
save it, how much bytes?
15.
Because space is also a ASCII
Yeah.
key. How computer will understand otherwise? So it should take how many bytes?
15.
Let's quickly see. 15 bytes. Excellent. Okay, so now you understood how computer understands only digits, binary numbers only, 0 and 1s. So whatever, whether it is any file, song, video, it is all for computers 0 and 1s only. Now only one question I have for all of you, that if I say C and I convert it, it's because C in ASCII table is 67 decimal. And if I do 67 decimal here, if I go decimal to binary and I say 67, it is also same. Its binary number is
Yeah.
same as. So how computer will know whether it has to, because computer has just stored 1010, but how program will know that it has stored C or it has stored the real 67 decimal that it want to interpret? It is through the programming language and the data types we assign to it. If we say it is string, it will show it
Yeah.
as C. If we say it is decimal, it will show it as 67. This is where the programming language and the software
Yeah.
comes, that converts it. Now, last thing before we close. So, can you see this binary for an image? Which image it looks like?
Batman. If you remove the ones and just focus on the zeros, it looks like the
So
Batman
yes, if you
logo.
just focus on the zeros, you will see how. So for computers, it's just zeros and ones. Though it is a Batman logo for us, but for computers, it is all zero and ones.
Ones.
So this is how you convert the decimal into binary, and this is what the 1 kilobyte is equal to 1024 bytes. Why? Because it is in the base
10.
10. Okay, thank you. Thanks for subscribing our channel, liking our videos. We will keep on making the content. Do share and like. Thank you.
Bye.